Usually when you look up at the night sky, there's this really comforting expectation of order.
Right, it's predictable.
Exactly.
Yeah.
You've got constellations, planetary orbits. I mean, the laws of physics are just ticking away up there like a giant cosmic clock.
Yeah, it's vast, but it obeys the rules, right? The rules we all learn in school.
Right. But today, we are taking a massive stack of sources.
That's right.
Declassified intelligence, astrophysics papers, deep statistical analyses, and it just completely shatters that clock.
It really does.
We are looking at a diagnostic landscape of humanity's place in the universe
Yeah.
that is, well, it's totally contradictory. It forces a fundamental rethink of what's actually possible.
Yeah, I mean, it is the absolute definition of ontological shock.
Oh, for sure.
We have hard empirical data pulling in two entirely different directions right now. On one hand, you've got undeniable documentation of craft-defying terrestrial physics right here in our own atmosphere. But then, on the other hand, we have these incredibly rigorous mathematical models suggesting that, realistically, we should be entirely alone in the cosmos.
Okay, let's unpack this.
Yeah.
Because we should probably start with the most immediate reason this topic is, dominating literally every conversation right now.
Yeah, the elephant in the room.
Exactly.
Okay.
The sudden shift of unidentified anomalous phenomena, or UFOs, from this fringe conspiracy theory to a documented, declassified reality.
It's been wild to watch.
It really has. We're looking at the May 8th and May 22nd, 2026 releases from the Pursue Initiative. That's the Presidential Unsealing and Reporting System for UAP encounters, for anyone who hasn't been following along.
Right, which is this mandated systemic unsealing of military records.
And the delivery mechanism itself is just so fascinating. I mean, they dumped this onto a public website, war.go UFO, with this really brutalist zero design aesthetic.
Oh, yeah, just pitch black background, stark white typewriter fonts.
Yeah. And they uploaded the primary source documents, complete with, like, the physical degradation of the paper. You can see the original declassification stamps, the coffee stains.
It's very raw.
Right. It subconsciously communicates that this is unedited intelligence, no political spin.
Well, the psychological framing there is definitely deliberate. I mean, by removing all the polish, the Department of Defense is really emphasizing the rawness of the data.
Right.
And the data itself, I mean, it forces us to confront mechanisms of propulsion that we don't just lack, we barely even comprehend them.
Yeah, like the 1997 Alaskan coast incident.
Exactly. You have a combined sonar and radar contact tracking an object, and they estimate it to be over 400 feet long, just operating right beneath the Arctic ice.
Wow.
And then it breaches the surface and enters low Earth orbit in under 3 seconds.
Which is insane. Just to put the physics of that into perspective for you listening.
Yeah.
Displacing that massive volume of water and then ignoring hydrodynamic drag to achieve escape velocity instantaneously.
Should be catastrophic.
Right. It should create this massive sonic boom and a thermal shockwave that would just vaporize everything nearby.
Yeah, absolutely.
To do that silently implies a complete circumvention of traditional aerodynamics. We're talking about, like, manipulating the local gravitational metric itself.
Right, so the craft isn't actually pushing through the water or the air.
Exactly. It's moving the space around it.
Which is totally corroborated by the 2019 USS Omaha incident, you know, the source of the infamous gimbal video.
Oh, right.
The unredacted telemetry from the Pursue release shows it wasn't just a single object. It was a whole fleet flying in a wedge formation.
A whole fleet. That's just wild.
And the DoD thermal analysis is the real key here, because the main craft wasn't reflecting heat from an engine exhaust.
Okay.
It was generating this intense, localized cold plasma field. By ionizing the air immediately surrounding the hull, a craft can essentially create a vacuum slipstream.
Right, which eliminates friction and aerodynamic heating entirely.
Exactly. It demonstrates a mastery of physics that makes our most advanced jets look like, I don't know, paper airplanes.
Yeah, no kidding. I mean, look at the 1994 incident at Eglin Air Force Base.
Mm-hmm.
These luminous disc-shaped objects were intercepted by F-15s, right?
Right.
And within 10 nautical miles, the F-15s experienced systemic failure of their military-grade shielded avionics.
Just completely shut down.
Completely. The objects projected a localized electromagnetic warfare capability that we literally have zero defense against.
Not all.
But out of all the 162 files in that initial release, the 1964 Holloman Air Force Base incident is the one that changes the entire context for me.
Oh, absolutely. The Holloman footage.
Yeah. Multiple 16mm cameras capture a craft landing on the tarmac, and 4-foot-tall biological entities disembark.
And the detail that the intelligence psychologists analyzing the footage noted is just wild.
That they were deliberately wearing regular trousers and T-shirts.
Right. The inclusion of human clothing on non-human entities. I mean, it is such a profound detail.
It really is.
It suggests a very calculated psychological strategy on their part.
Yeah, it's like finding out Bigfoot is real, but he's wandering through the woods wearing a three-piece suit just so he doesn't scare the hikers.
That's a perfect way to put it.
I mean, it implies they understand human psychology well enough to try and minimize panic.
Yes, exactly.
But it also highlights the intense friction in our society right now. Because you have these hyper-specific military reports detailing beings in T-shirts, and then you have extreme skepticism still dominating the public discourse.
Right. You've got some skeptics dismissing the Holloman footage as, complex camera artifacts or elaborate 1960s hoaxes.
Yeah, and then at the exact same time, you have Christian pastors holding emergency meetings, warning their congregations that acknowledging these files could fundamentally shatter their community's faith.
It's a massive spectrum of reactions. And to be completely clear, we are just neutrally reporting on how people are reacting here. We aren't taking a side or endorsing either the religious or the skeptical viewpoints.
Right, absolutely. We're just laying out how society is actively processing this data.
Because we are watching a global society process ontological shock in real time.
Yeah.
It's fracturing into denial on one end and existential crisis on the other. What's fascinating here is the specific redaction protocol the government chose to navigate all this.
The way they censored the files.
Yeah. In the PRSU files, the military has meticulously excised any data regarding how our sensor platforms work.
Right.
So the radar resolution limits, the specific classified frequencies, all of that is blacked out. But they left the UAP data completely untouched.
Where?
The speeds, the trajectories, the morphology, the thermal signatures, all of it is there.
So they're hiding the camera, essentially, but showing us the exact unaltered picture.
Precisely.
Which means the military is effectively shifting the burden of analyzing these impossible kinematics away from their own classified defense programs.
Yeah, they're just dumping it right onto the global scientific community.
They're telling civilian scientists, hey, here is the raw data of what is in our skies. We don't know how it works. You figure it out.
It was luck. Yeah.
Exactly. And if we accept the reality of these physical craft, the immediate next question is, well, where do they physically originate?
Where are they coming from?
Which takes us out of our atmosphere and into the cosmic real estate available for life. Specifically, looking at the data from the Kepler Space Telescope.
Yeah, Kepler really revolutionized our understanding of planetary frequency. It gave us the statistical baseline for the universe.
Okay, lay it on us.
So, a major study in the Proceedings of the National Academy of Sciences analyzed the occurrence of planets that are 1 to 4 times the size of Earth.
Okay.
And we now know that 26% of sun-like stars have small planets, meaning 1 to 2 Earth radii, sitting within a 100-day orbit.
That's a lot.
It is. And furthermore, 11% of those sun-like stars have planets in the habitable zone, receiving 1 to 4 times the sunlight that Earth gets.
Okay, 11%. That is a staggering amount of potentially habitable real estate when you look at the whole galaxy.
It really is. But the study points out a crucial dividing line at exactly 1.5 Earth radii that dictates whether a planet can actually support life.
Right, the density issue.
Exactly. Below 1.5 Earth radii, a planet is rocky, and its density actually increases as it gets larger.
Because the sheer mass of the planet causes immense gravitational compression of the rock and iron in its core.
Right, it gets squeezed tighter. But the moment a planet hits that 1.5 radius threshold, the physics just flip, and the density drops sharply.
Oh, wow.
Yeah, the gravity becomes strong enough to hold on to the lightest, most primordial gases from the stellar nebula.
Like hydrogen and helium.
Exactly, before the young star's solar wind can blow them away. So instead of a larger Earth, you get a mini Neptune.
Oh, okay.
It has a rocky core, sure, but it's crushed beneath a massive, suffocating, low-density envelope of gas or, supercritical water.
Here's where it gets really interesting, because it frames planetary formation as a highly sensitive cosmic baking recipe.
A baking recipe, I like.
Right. Did Earth just get lucky with the ingredients available when it formed? Because it all comes down to the metallicity correlation.
Yeah, the Kepler data shows that giant gas-rich planets tend to form around stars that are rich in heavy elements.
Which is counterintuitive. I mean, you'd think a star system full of heavy elements would just produce massive heavy, rocky planets.
You would think so, but it's actually a race against time. Protoplanetary disks, those swirling rings of dust and gas where planets are actually born, they lose their gas very quickly.
Usually within a few million years, right?
Right, so if a star system has an abundance of heavy elements, the rocky planetary cores form extremely fast.
Okay.
They grow massive enough, quickly enough, to sweep up all that hydrogen and helium before the gas dissipates into space.
And if a system doesn't have enough heavy elements,
Then the rocky core takes too long to form. By the time it hits that critical mass, the gas is already gone, leaving behind a bare rock.
so Earth basically sits in this incredibly narrow sweet spot.
Very narrow.
Our specific stellar neighborhood had enough heavy elements to allow for complex biochemistry. We have carbon, oxygen, iron, but not so much that our core formed fast enough to trap all the primordial gas and turn us into a mini Neptune.
Exactly. We threaded a very specific astrophysical needle.
Wow. Okay, so if you put these two pieces of data on the table, you've got 11% of sun-like stars hosting planets in a habitable temperature zone, and then you have the PRCU files showing physical craft maneuvering in our atmosphere.
Right.
It completely forces a confrontation with the Fermi Paradox. I mean, if habitable planets are everywhere, and visitors are apparently here, why does the rest of the observable universe seem completely, terrifyingly dead?
It's the ultimate question, and our source stack includes a massive 2018 paper from Oxford University by Sandberg, Drexler, and Ord that completely upends our historical approach to this silence.
Yeah, they really took aim at the Drake equation, didn't they?
They did. They targeted the Drake equation, which has been the standard formula used for decades to estimate the number of active communicative extraterrestrial civilizations in the Milky Way.
Right, it's the classic formula everyone learns.
Exactly. And the Drake equation basically multiplies several factors together. The rate of star formation, the fraction of stars with planets, the fraction of those planets that develop life, the fraction that become intelligent, and so on.
Right, but the Oxford researchers found a fatal flaw in how we were using it.
A massive flaw. They demonstrated that scientists have historically relied on point estimates for these highly uncertain factors.
Meaning they were just guessing a single, plausible-sounding number for each variable.
Yeah, just picking a number. Assuming, for example, that there is exactly a 1% chance that a habitable planet develops life.
Right. It's like trying to predict your lifetime earnings. If you just guess that you will make exactly $75,000 every single year until you retire, your math is going to look incredibly clean. But it is guaranteed to be wrong. You haven't accounted for the real-world variance at all.
Exactly.
To get an accurate picture, you have to use a probability distribution.
Yeah.
One that factors in the chance you might invent a billion-dollar app or, the chance you might go completely broke.
Right, you need a range of possibilities.
Yeah.
And when scientists multiplied a bunch of highly uncertain, optimistic single numbers together in the Drake equation, it created a mathematical illusion of certainty.
Oh, that makes sense.
It artificially inflated our confidence that the galaxy must be teeming with life.
So what happens when you fix the math?
Well, the Oxford paper introduces those realistic probability distributions, particularly focusing on the biological uncertainties, and honestly, they are staggering.
Yeah, they mentioned the Leventhal protein folding paradox, right?
They do. Proteins are the fundamental building blocks of life, and they must fold into highly specific three-dimensional shapes to actually function. If you assume a simple protein chain has to randomly search through all possible physical configurations to find the correct fold, the math dictates it could take orders of magnitude longer than the entire age of the universe.
Wow.
Just to fold one single moderate-sized protein.
Which means the initial hurdle of getting life started, that pre-evolutionary leap from dead chemistry to self-replicating biology, it might not just be hard, it might be astronomically improbable.
Yes. The uncertainty of that single step stretches across hundreds of orders of magnitude.
Is wild to think about.
And when the Oxford team ran the Drake equation millions of times using these vast probability distributions instead of single guesses, the conclusion was incredibly stark.
What were the final numbers?
They found a 52% chance that we are entirely alone in the Milky Way galaxy.
More than a coin flip.
Exactly. And a 38% chance we are alone in the entire observable universe.
Okay, so if the hard mathematical reality suggests there's a coin flip chance we are the only living things in the galaxy, how do we explain the biological entities stepping onto the tarmac at Holloman Air Force Base?
Well, if we connect this to the bigger picture, the Oxford paper doesn't actually prove that we are alone.
Right.
What it proves is that we shouldn't be surprised that the sky is quiet. It effectively dissolves the mathematical paradox.
Okay.
For decades, scientists have invented these wild, speculative theories to explain the silence of the cosmos.
Right, like hypothesizing that alien civilizations are hiding in a dark forest to avoid predators,
Yeah.
or that they transcend into virtual reality.
Exactly, but the Oxford math shows we don't need those extreme theories. The silence is just the expected baseline.
Got it.
However, that expected silence does not mathematically preclude a statistical outlier from actually existing and visiting our atmosphere.
And to be that statistical outlier, to be the species that builds the craft seen by the USS Omaha, a civilization has to survive a brutal gauntlet of cosmic hurdles.
Absolutely brutal.
Which brings us to the concept of the Great Filter. This was proposed by Robin Hansen back in 1996.
Right, a classic concept.
The hypothesis states that in the evolutionary path from a dead rock to a galaxy-spanning civilization, there is at least one step that is incredibly improbable.
A filter that almost no one passes?
Exactly. Hansen outlines 9 evolutionary steps. It starts from having the right star system, moving through single-cell life, complex multi-cell life, intelligent tool-using animals, all the way up to an interstellar colonization explosion.
And the big existential debate is whether this great filter is behind us or ahead of us.
Right.
Because if the filter is behind us, perhaps at step 4, the initial creation of the complex eukaryotic cell, then humanity is the lucky lottery winner.
We survived the hardest part.
Exactly, and the future is an open frontier. But if the filter is ahead of us, it means that life routinely evolves to our current technological stage and then, reliably, predictably, gets wiped out.
Which is terrifying. And paleobiologist Olive Vinn proposes a deeply unsettling theory for a filter ahead of us. It's centered on inherited behavior patterns, or IBPs.
Yeah, this one is rough.
The premise is that the exact biological instincts required to survive the primitive stages of evolution, aggression, tribalism, intense resource hoarding, zero-sum competition, those are hardwired into a species.
Right, they're baked in.
And as that species develops godlike technology, those inherited jungle instincts become fundamentally incompatible with their survival.
So the civilization inevitably self-destructs.
Because they have the weapons of gods, but the psychological wiring of apes.
Exactly. Alternatively, there's the berserker hypothesis.
Oh yeah, the AI one.
Right. This posits that civilizations don't self-destruct, but they are actively eradicated.
Okay.
If one early civilization decides to build lethal, self-replicating von Neumann AI probes and programs them to eliminate any emerging competition,
Oh man.
yeah, those probes would systematically sterilize the galaxy, acting as an artificial great filter for everyone else.
So, assuming a species avoids self-destruction and AI eradication, surviving the filter essentially means transitioning into a planetary civilization.
Yes. On the Kardashev scale, which measures a civilization's advancement by its energy consumption, this is a Type I civilization.
Okay, what does that mean practically?
It means successfully harnessing all of the solar energy hitting the home planet. For Earth, that is roughly 10 to the 17th watts of power.
Wow.
A Type I civilization has total mastery over its planetary environment. They control the weather, they can harness the kinetic energy of hurricanes, mitigate earthquakes.
And build massive ocean or atmospheric cities.
Exactly. It is the realization of the classic Buck Rogers or Flash Gordon science fiction utopias.
And physicist Michio Kaku suggests that, based on our current trajectory of energy consumption and technological growth, humanity could theoretically reach Type I status in just 100 years.
Just a century.
So what does this all mean? Because a century is a literal rounding error in cosmic time. If we are standing that close to the finish line, what is the immediate threat keeping us from crossing it?
Well, this raises an important question, and Kaku provides a very specific sociological warning.
Okay.
He argues that the greatest danger of transitioning to a Type I planetary civilization isn't an external threat like an asteroid or an alien invasion.
It's internal.
Exactly. The threat is internal. The transition requires moving toward a highly tolerant, multicultural, scientific, and globally integrated society.
Right.
And Kaku analyzes forces like terrorism and extreme nationalism not simply as political movements, but as violent, monocultural reactions against that planetary transition.
Interesting.
They represent a fundamental rejection of modernism and scientific integration in favor of historical theocracy and tribalism.
And again, we want to make it super clear for you listening, We are strictly impartial here. We are just presenting Kaku's sociological analysis neutrally.
Yeah.
We aren't taking any political sides.
Absolutely. We're just looking at his theory. And his theory is that the ultimate test for humanity is whether the push toward a unified planetary civilization can survive the friction generated by those inherited behavior patterns.
So we are caught in this incredible tension right now.
We really are.
We have the cold, hard Oxford statistics demonstrating that life is incredibly rare, that the universe is mathematically expected to be silent, and that the biological hurdles to existence are nearly insurmountable.
Right.
And colliding with that exact math, we have the explosive, declassified PRC files showing physics-defying craft, treating our most advanced military airspace like a playground.
Confirming that someone somewhere actually beat the odds.
We are a species standing on the absolute brink of either passing the Great Filter and joining them, or failing it and becoming just another dead rock.
And that tension points toward a final thought that really synthesizes this entire diagnostic landscape.
Let's hear it.
Consider the 1964 Holloman Air Force Base report again.
Okay, the biological entities stepping out of a transmedium spacecraft.
Right. And they are wearing human T-shirts to minimize panic. Now overlay that with Olevin's theory of inherited behavior patterns causing inevitable self-destruction.
Oh, wow. If an advanced civilization has already survived the Great Filter, they possess a deep, intimate understanding of exactly how dangerous a young species' primitive psychology can be.
Yes. They know that giving a tribal, aggressive species undeniable proof of a larger cosmic hierarchy could trigger mass hysteria, societal collapse, or a violent, fearful lashing out.
That makes total sense.
Maybe the final Great Filter isn't a dying star or nuclear winter or a rogue AI. Maybe the final test before a species is allowed to integrate into a wider galactic community is purely psychological.
Can a species handle the ontological shock of realizing they aren't the main characters of the universe without destroying themselves in a panic?
Exactly. Look at our own society's fractured, chaotic reaction to these declassified PRC files today.
Yeah.
Are we taking that exact test right now?
That is the thought to keep you up at night. The data is out there, the math is unforgiving, and the clock is definitely ticking. Thank you so much for joining us on this deep dive. Keep looking up, keep asking the big questions, and we will catch you next time.